Raylib is a cool library, but I also want to make my own library, which I mean I've already done 1 billion times, but still. And there's a bunch of stuff you could do for your library. For example, little let's see, yep, little platform layer, for xlib and win32. No big deal, right? GL context creation if you're gonna use OpenGL, or it's basically multi-platform stuff, right? That's probably the first thing you're gonna start by doing. The second thing is probably the render, which I'll just let's make a little example. So here it's gonna be CC is literally CC. C compiler flags is gonna be std 99 WO. Fuck warning. I keep warnings. And yeah, and the linker flags. What we're gonna need is I'm just gonna use GLFW and glue because I have them installed globally on my system, so it's kind of convenient if I use them. You know what I mean? Yeah, I'm gonna use debug mode by default. So the C compiler with the C compiler flags, really cool. Main.c. And also, I forgot about. Actually, no, I didn't. I didn't. Bin out. No, no, no. Let's just do this. Don't need no directories, and then the linker flags. And because this is debug, we're gonna have zero optimizations, debug symbols just in case we use the debug thingy. And last but not least, do. I mean, define debug, that's for sure. But I mean, fuck it. Let's turn on address sanitization because I want to try it, I guess. And we're just gonna do the same shit for release, but this time, uh, just gonna replace everything with just 303. And yep, that's pretty much it. Let's just do the most basic example of OpenGL ever. I should probably pause the video or keep the video. Fuck it. Just do our int main. I'm not even gonna do any error check-in. Do it yourself. This isn't supposed to be about that. GLW creates window. And before that, actually, before I forget, let's do the whole GLW window. And GLW isn't the best thing. I'm not using it because it's the best thing in the world. I'm just using it because it's there in my system. GLW OpenGL profile is gonna be GLW core profile. So OpenGL core profile. We're gonna be using OpenGL 3.3, pretty standard. So GLW context version measure 3, same shit, except this is going to be minor. There we go. Last but not least, I'm just gonna make the window not resizable. Just because, I don't want to like switch to floating mode and tile mode in my window manager. So GLW resizable, GLW false. And here I'm just gonna do it 800 by 600, then it's just gonna be test. No display, no thingy. GFW make context current window. While we shouldn't close the window, it's just a loop. And here we do a little terminate. GFW destroy window instead of create window. Man, this is unnecessary. I wanted to focus on the render already, but I have to like go through GFW now. GFW swap. We swap the buffers because we're double buffering in OpenGL. And last but not least, we just do a little GL clear, GL color buffer bits. And here we set the blue initialize GL clear. We set the clear color to gray. Right, just a nice little gray. Just make file reference to GL clear color. Do I have to do GL? I do. Cool. Wow, amazing. Now, next thing we should do, just delete this. Next thing we should do is I'm gonna do everything in one file, I guess, because having multiple files is kind of necessary in this case. So what we're gonna do is let's open up Krita first because I kind of want to draw something. Basically, what we're gonna do is when you we have a little vertex buffer. Okay, we have a little vertex buffer. So this is our quad. We know GPUs render triangles. So this is our little quad, which consists of 4 vertices and 6 indices, which, connect this. So this is 3 indices, and these are 3 indices. Kind of, I'm not here to explain learn OpenGL.com. I'm here to explain batch rendering. So yeah, that's our quad, right? Here are vertices. So for each quad, we have a vertex buffer. We have vertex buffer object in OpenGL. We have an index buffer and a vertex array. For the whole freaking vertex layout and shit. And in the game loop, what we usually do, and I'm talking about 3D in this case, what we usually do, the standard way of doing it, is we draw the object, whatever. Let's say we're drawing a bunch of cubes. We draw the cube, then we change the position and change the texture, so GL bind texture, whatever, and like change the model matrix, or whatever, right? And then draw it again. Change the position, change the texture, draw it again. Change the position, change the texture, draw it again, and possibly even like change the vertex array, so we change the entire model. And that is basically it. But the overhead on a single GL draw call is pretty damn big, and we're just doing a shit ton of draw calls here. What we're gonna do is we're gonna have a single huge vertex buffer and a single huge index buffer, and we're gonna batch all the vertices and indices. So basically, whenever we want to draw something, whenever we say gfx draw rect, instead of making an actual draw call, all we do is we set well, okay, let's say we have like 3 quads that are already drawn in the screen. Well, if you call gfx draw rect, we're just gonna go to the 4th slot, right? We're just gonna fill in a bunch of vertices, and that's it. Fill in the vertex, the positions, the texture coordinates, the colors, and that's it, right? And that is pretty much it. And then we have basically, since we have a single vertex buffer and index buffer and all that, we use a single draw call. We have all the vertices in a single buffer, so we just use a single draw call to draw all of these, and that's it. There are some drawbacks with this approach, though, because now you can't switch the texture between these anymore. When you draw these little quads, you can't switch the texture between them anymore, which is kind of a problem, right? And now they all use the same shader, because again, you can't call GL use program or GL bind texture between the draw calls. So you have to improvise. First of all, for the sprite, I'm gonna have a second video because it's this video is gonna be way too long, right? All we're gonna do is load all of the images that we're gonna need for our game. So like, let's say the player.png, the enemy.png, the bullet.png. This is just an example, by the way. Okay, we're just gonna like get all these images, load the pixels using STB image, get all of them and combine them into a huge image called the Sprite Atlas. Okay, we're gonna use that. You're gonna do that using STB Rect Pack. It's a pretty good. STB libraries are just beautiful for game dev. I'm just saying. And yeah, once we just have a huge sprite atlas which has all the images we'll ever need in a single image, right? Then we assign UV coordinates to each sprite. Okay, so now whenever I want to like draw this is the player, and this is the enemy, and this is the freaking bullet, right? I'm not good at the mouse sucks for this, but yeah, if we want to draw the player, the texture coordinates for these vertices are gonna be mapped to this. This is the player, for example, and this is the enemy. For the enemy, we're gonna be using these UV coordinates. For the player, we're gonna be using these UV coordinates, etc. So we're just gonna draw everything from this sprite atlas. And this is the same technique we're gonna do for font rendering. We're basically just gonna take a vector font, so like a TTF file or whatever. We're just gonna take it and we're just gonna rasterize it using STB true type. We're just gonna rasterize it into raw pixels. And we're gonna have a font atlas. It's not gonna be a sprite atlas. It's gonna be a font atlas. It's gonna have A, B, whatever. It's gonna have all the letters and shit. All the ASCII characters we'll need. Basically, we're just gonna rasterize it because who in the right mind thought fucking vector fonts were good? Vector GPUs were not meant for vector graphics, but that's a topic for another day. We're just gonna rasterize them, so we're just gonna be like, no, f your vector graphics. We're gonna rasterize these using STB true type to raw pixels. That is basically our drawing approach. Now let's just draw basic rectangles. So just close out of this. There we go. So yeah, now that we got a little OpenGL window, let's just start by making a render.c, because why not? Some people might like to. I'm gonna do this very simply, you know. I'm not gonna do this with any approaches to, you know, like supporting multiple graphics APIs or any of that. This is just gonna be me programming shit. So yeah, render.c, which I'm just gonna include here, right? And what the API is going to look like, I'm thinking something like this. So when we initialize OpenGL, all we're going to do is something like render. I'm not going to name it render. How about this? Wait, no. I'm just going to name it GFX instead. So delete this, make a gfx.h. That's it. And here, rename it to GFX. So basically, all I want to have is a GFX initialize, right? And here, instead of doing GL clear, we're just gonna have GFX begin, GFX end, and between these, this is kind of similar to Raylib, by the way. And between, I'm probably gonna pass in the camera here, so like, gonna have something like GFX camera, GFX. I'm just not gonna separate it even. GFX camera, which equals to GFX camera. Or we're gonna have, I mean, I think the only thing we need to set here is the zoom, which is gonna be equal to 1, and then we're just gonna put it here. And we're just gonna have shit like push rectangle, because again, it's not really drawing, it's just like pushing stuff to the quads or whatever. Now, what do I mean by that? I'm just gonna define a bunch of things. So GFX max quads, the maximum amount of quads, because we're just allocating a huge vertex buffer, right? So we're just gonna have, I don't know, 4,000 quads or something. I think that's plenty. GFX max vertices, which is literally just GFX max quads multiplied by 4, right? And by the way, yeah, as I said, the sprite add is going to be for the next video. Please wait. Type def struct. I don't even need to make it a type def struct, but I'm gonna make it a type def struct anyway. GFX render data. I'm gonna name it GFX render data, which is gonna have basically all of the rendering data we will ever need, basically. And we're just gonna allocate that in GFX on the initialize. And I forgot to make a GFX uninit function, or maybe we wouldn't even. I'll do it anyway. So we're just gonna clean up everything. So yeah, we're gonna have a bunch of types here. So first of all, we're gonna need the quad we were talking about. The quad is gonna be a bunch of vertices. So wait, just delete this. I need a math library. You forgot. I need a math library. What math library should I think CGLM will do the trick, even though I'm not sure if I have it installed in my system. So CGLM, is it? Yay, CGLM. Wait, let me. Damn it, everything froze. CGLM. Okay, yes, it is CGLM. Just install it from the AUR. This is CGL. It's literally just GLM, but it's C, so it's like a math library. It's pretty good. It's my favorite math library. I'm gonna be using the struct API because maybe for vertices I don't need the struct API. Who knows? We'll see as we go. Oh damn, we're building the whole thing. I thought we could just do the. Sure, okay. Yep. So let's include CGLM. Let's make sure this still compiles, which it doesn't. Implicit declaration. Oh yeah, right. I was just like hallucinating what these functions are gonna do. So now we no longer can compile. Let's just do this. Void GFX begin, which is gonna require GFX camera. So, camera. Do this. GFX end, which is gonna be void. I forgot to do void here too. I can make these static functions, but who cares? Push rects, which is gonna require a bunch of arguments. So push rect is gonna like we're gonna give it the actual rect, right? So I'm thinking we make a GFX rect, and here we just make that. The rect isn't gonna be. It's not really gonna be the same as a quad because the quad is gonna just wait. A rect is gonna be something like this: vector two s. Again, I'm using the struct API because a vector two in CGLM is literally just an array of floats. Okay, so it's literally this type def floats vector two. That is basically it. What I want instead is this vector two s, and it's just. And technically, they're using unions, so it's more like this. Wait, why did I delete that? Wait, no, get that back here. Yep, and they have, well, yeah, and also the raw. And I think, I'm not sure, but I think the reason they're doing a union, I think the reason why they need access to raw is because of like SIMD instructions. I am not sure, but yeah, just use this one. We're gonna have the position, the size, and the color, and that is basically it. A vertex is gonna have a position, and it's gonna have a color for now. Next time I'm gonna do. And also, if we want to differentiate between rectangles and sprites and all that, we're just gonna add a little. We're just gonna add a little float called texture ID. Okay, so if texture ID is 0, we render a rectangle. If texture ID is 1, we render a sprite. If texture ID is 2, we can render a font. We can render a character from a font, basically. Because again, we're using the same texture. We can use multiple textures at the same time, and that's how we differentiate between them using text ID. I'm not gonna, but we're eventually gonna run out of texture slots. So yeah, I'm only gonna use two texture slots again, the one for the sprite atlas and one for this font atlas. I think that's generally a better approach for this. I also forgot GFX uninit. That should compile now, which really didn't because I forgot the little camera. Type def struct GFX camera, which we're gonna have the zoom, we're gonna have the position, and we're also going to have the matrix or projection matrix. We're going to have the projection matrix. We don't really need the view matrix. I'll add it when I need it. And we still have a bunch of errors because I forgot that I need to include struct.h. Push rect. Too many arguments. Just pass nothing. Just pass 0 for now. Just want to compile this shit. And yep, it works. So, again, all we're gonna have is a quad. So let's add the quad here. And a quad is literally just 4 vertices, just like that. And we're just gonna have an array of quads. So GFX quad, a bunch of quads, and it's just gonna be GFX max quads. And we're just gonna have a little counter. So you can just damn it, include std ints. And let me differentiate it from the other. We're also gonna need std lib for allocating, because you might have a lot of freaking quads, a shit ton of quads, and you want to like heap allocate the render data instead of you know stack allocating this, which yeah, I'll just do right now. GFX quad, yes, UN32 quad counts. We can also make it a 64 if you want. This is what we're gonna use to index into this array, basically. So each time we draw a little rect, we're just gonna check. Okay, first of all, we're gonna check if the wait GFX render. I'm just gonna make it global because I don't want to deal with other shit. GFX render data RD. I'm just gonna name it RD for render data. So each time, if the quad counts is bigger than, is it greater than or equals to GFX max quads, then we're just gonna do a little stdio. Then we do fprintf in stdr. Uh, ran out of quads, basically. So you get the idea. We're just gonna exit with the 1. So, but when we do push our quad, we're just gonna do this. So RD quads. or the quad counts. Or you know what? Since we're like indexing into it so much, let's just do quad, which equals to this. Because again, indexing into an array is pointer arithmetic. It's basically just pointer arithmetic, and you know it involves multiplication. You know, so like we don't want that, right? Quad zero, is that gonna work? Yeah, it will work. Come on. Quad zero is going to equal to gfx quad. So we're just gonna set it to rects dot position dot x, rect dot position dot y, and then the color of our vert. Oh wait, no. This go back, go back, center this, go all the way here, and change it to zfx vertex. So we're setting each vertex of this quad. You know, all the four vertices we're setting them manually, and each vertex has a position, a color, and a texture ID, right? So we're just gonna do that. We're gonna have a position. So yeah. No wait, why did I delete that? So a position, a freaking color, which I'm just gonna pass right here. So color is gonna be vector 4s. I mean, no, everything is there. So why am I doing that? Rects dot position, rects dot color, and then the texture ID, which is 0. I'm just gonna add a bunch of info here. So texture ID 0 equals rect, 1 equals sprite. Just to like keep up with it. So just in case we don't forget. And then here we do art. That is basically. I'm just gonna copy this a couple of times. No, wait, nope. And here, what we're gonna do, I wish I had Krita open, but basically it's just something like this. Rect up. Basically, we're just gonna start with this vertex. We're gonna have this is our rectangle. This is our rectangle. Just imagine it in your head. Use your imagination. We're gonna start with this. So 0, 0, and then here. So 1, 0. Then we're gonna do the here. So 1, 1, and then 0, 1. Basically. So this here, here, here. So let's just do exactly that. Dot size dot x, and then just leave the position y. Do just that, but this time index into 2 and do a little plus here. So rect dot size dot y, and last but not least, just do the same shit here. And that is basically it. Let's check if it still compiles, which it doesn't. Why is it not compiling? Conflicting types or GFX? Okay, what did I fuck up here? Up, yep, there it is. Another error, which is undeclared. Hey, why am I using the terminal for this? Why not just use run mode? Let's just go here. So we have this error, which is easy to fix. And these are just assignment to expression with array type. Hmm. Yo, just watch me struggle, cat. Just so this is a pointer to one of the quads. And each quad in itself is an array of vertices. We're already indexing into this, right? So shit, yeah. Just gonna do a little cast gfx vertex. So it's an array of vertices. I wanted to access it as an array of vertices, not a single quad. Although I'm not sure if that is gonna work. Rect.position.x vector2s has no member named s x. which is no, absolutely not. It is literally literally using the struct API for this, so should have that. Was there some kind of macro I had to for anonymous? Yep. So how did you do that again? Wait, v user includes cglm structs.h anonymous. No, never mind. Let's go into here. There's something about user includes cglm and just see anonymous. Anonymous. Yes, cglm use anonymous struct. Define cglm use anonymous struct. Define one. And it's even worse. Oh yeah, right. So let's just do one of these. Let's do a little bit of vim instead of just suffering like this. Also, I forgot to do this. This is basically just making shit look nice. It's not really useful or anything. Missim braces around initializer. Bruv, I already did this. What do you mean? Ignore the warnings. That's why I hate the warnings for this one. We have a segmentation fault, which is even nicer, and I also know why. It's because we didn't allocate shit. So here, so we just render data equals to calloc one size of dereference it, and then here we just free it, separate them a bit, make it look nicer, and there it is. Also in GFX begin, let's just do a little uh, GL clear. Let me just move this here. And here, let's just GL clear buffer bit, color buffer bit. We're just gonna clear the color buffer, not the div buffer. We don't need that. And now, if I push an actual rect, which nothing is gonna happen by the way, because we haven't done anything GPU related. So like, let's do that. That's probably important. But let's just set up this one first. So here, vector 2s. You're gonna do the position is gonna be for now is gonna be 0 0 0 0. How am I doing 0 0? I can just do this. And it's just gonna zero initialize it for me. So I'm gonna just set the size alone, which is going to be 1 1, by the way. So 1 1. And that's gonna be for a reason. Basically, we're just gonna use the normalized device coordinates for now. I'm not gonna I'm gonna start with that, and then I'm gonna do the whole camera projection thing. But we forgot something, which is the actual shaders. I'm just gonna put the shaders right here. I'm not even like separate them into a separate file or anything. Just gonna like put them here. So static const character pointer vs vertex shader source, which equals to we're gonna be using GLSL 330, and all we're gonna do is we're gonna take in again. Here's our vertex, as I said. We're gonna take in our vector 2 position. And same shit for this. So 1, 2. Here it's going to be a vector 4, and here it's going to be a single floats. So here we're going to take in the color, and here we're going to take in the attribute texture ID. And then we're just going to like output all of them. So literally just vim, I guess. So change to outs. Just delete all these and just return it. Do a little void main. Close this. And here, all we do is set the GL position to a position. And sets all the other bullshit. So the position. Wait, why am I outputting the position again? Hell no. The color is going to equal to a color. and the texture ID is going to equal to the a text ID. Then static const character pointer fragment shader source. Man, I wish I had the C++ feature where I can just do like the R parentheses, and I can just have multi-line strings pretty easily. But what can you do? I'm just gonna take these two, right? I'm gonna go down here, put all of them here, and just change this to in. And here, what we're gonna do is if the texture ID equals to 0, I'm gonna point 0 because fuck precision. Then we'll just do the output color is going to be a simple simple rectangle. I mean, so yeah, equals color. But if we're just gonna do like else if text ID is something else, then we can use the sprites and all that, the sprite atlas and all that. But right now we don't have that, as I said. And let's just do the incredibly annoying task of setting up OpenGL shaders. So the OpenGL shader, we're just gonna have a bunch of GL stuff here, GL specific stuff. So GL, which is literally just a bunch of IDs, a bunch of handles to a bunch of objects in the GPU. And I don't know how OpenGL works from the back. I haven't read the Mesa source code or anything. So union 33-2 can have the VBO, IBO. So the vertex buffer object, the index buffer object, the vertex array object, and the shader program. So shader. And by the way, this shit is not random. I'm trying to do struct alignment here. Okay. Basically, I'm just gonna make this very easy, right? Without going into the details, a 4x4 matrix is the biggest data type here. So this is going to be at the top. And then vector 2s is two floats, so it's going to be here. And the float is going to be here. It doesn't exactly work like that, but just do it this way so you avoid, struct alignment issues. And yep, that is basically it. And GFX end is where it's gonna like go through our GFX quads, upload this to the GPU, and then we just render that shit. So let's do that right now. First of all, let's like initialize shit. So let's initialize shaders. First, we're gonna need shaders. So UM32 vertex shader and fragment shader. The results for error handling and the info log for the actual, error messages. And that is basically it. So VS is gonna create the vertex shader first. We're gonna take the shader source. So basically, we're just gonna give it the VS SRC that we made. We have one source, which is this, and then we only need the length. No, the compile shader. When we compile it, let's get the compile status. So GL get shader IV, GL compile status. Give it the memory address of results, so we can modify. And if we fucked up somewhere, well, first of all, we're just gonna exit the program. That's for sure. std error. Failed. No, vertex shader compilation failed. Error. We're gonna give it the actual string info log. And to get the actual info log, there's literally a function called get shader info log. We're gonna use that. That shape. I usually memorize OpenGL functions. I kind of forgot this one. No, and then info log. I need to check docs.gl for this one. So docs.gl, pretty useful website. You should check this one out. Man, it's so slow. So looking at the GL 3.3 specification, we need the shader, the max length, which is 1024, is just hard coded. The length, which is null because I don't need it, and the info log. So yes, I was correct. Wow, how cool. So you're just gonna get the error, and then we're gonna literally just copy all this and paste it here. Here I'm just gonna replace everything VS with FS like this. Change this to fragment shader, and change this to fragments shader. There you go. Last but not least, I'm literally just gonna get this again. Do this. And instead of compile shader and shader source, I'm just gonna do GL attach shader, render that shader, no, GL dot shad, and then what is it again? Oh yeah, VS FS. This is going to be GL. Wait, we'll just let the thingy do it for me. So shader program, shader program linking failed. I'm just gonna go here, replace every FS with render data vl.she, do it globally. And oh god, I made a mistake here, that is for sure. And let's do the same shit, but this time, replace shader with the program, which is already kind of wrong here. Shader. This looks not correct because I just discovered this is GL link status, not GL compile status. But yeah, I guess that's literally it. So now that I got the shaders out of the way, actually no, wait, GL delete shader. Here, what we're gonna do is GL use program. We're gonna use the actual program, and also because we're gonna have a basically a uniform location, right? I'm just gonna store the uniform location instead of calling GL get uniform location every frame. So uniform projection location. Also, here's a much better approach to doing uniforms in OpenGL. Just go to Odin, vendor OpenGL, go into helpers, and just go into this function, get uniforms from program. Basically, what you can do is get program IV. You can get all the active uniforms, Just make a hash map. You could make a hash map, and the hash map looks something like this. No, not really. Where is it? It's not here, I guess, but oh, there it is. There it is. This. You can make a hash map where you can use a string, and this is gonna point to, like the uniform location, right? So you can just get active. You can use this function get active uniform for each index that you loop through. So basically, here you get how many uniforms you have in your shader, right? How many active uniforms? Because sometimes uniforms are not active, and then you can just loop through them, index through them, as you can see this little iterator over here. Just get their names, and then assign. As you can see, it's just assign the. I think I have an example for this. I probably deleted that example, but yeah, basically using a hash map to get the location instead of calling GL get uniform location every single frame. Much better approach, but I'm not gonna do a hash map right now because I'm in C. So let's actually let's actually allocate the buffer. So GL gen buffers. Let me just do that. To a little trick. GL VBO. If we go to GFX, go to vertex, no, don't render. There we go. As you can see, these two are literally next to each other, so might as well just give it the memory address of this, and we'll just go through two of them. GL bind buffer. We're just gonna make the VBO a array buffer. So this is the vertex buffer basically. Okay, GL buffer data. We're just gonna fill it with. We're just gonna like fill it with zeros. So array buffer, and then uh, GFX max vertices. We're going to have a bunch of vertices multiplied by the size of a single vertex because we're doing this in bytes. We're gonna give it null. And yeah, GL dynamic draw, so we can modify this buffer every frame basically. But the indices, however, the indices are just going to be a single array because we can just pre-calculate the index because all we're rendering are just quads, are just rectangles. We can just pre-calculate the indices. We don't need to like update them every frame or anything. So max quads multiplied by 6. So yeah, each quad has 6. So like we can just do that. Now we can just loop through these bad boys. GFX max quads I plus plus. And I honestly forgot how to do this. I might have to like go somewhere and copy it or something. Although I'm pretty sure I lost the files to my last render, so We'll see, because this is just one of those things that I don't memorize, because I don't memorize rectangle vertices, or rectangle indices, or any of that. I just hate that shit. I usually just copy them from learnopengl.com, as everybody does basically. So let's see. Let me just copy them. Well, with the magic of pause and unpause and via the OBS Studio, we have indices now. It is honestly pretty simple, but I still will not figure it out. Shut up. So I'm too lazy to type. Let me just like copy this. So instead of the dynamic draw, we're just gonna static, because we're never gonna modify this ever again. And instead of null, we're just gonna give it our indices that we just worked so hard for. And here, max vertices. No, not really. We're just gonna have max quads multiplied by 6. Or actually, no, 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 no. Instead of all of this, because indices is just like this array, it's a compile time non array. We can just do size of indices, and it'll just work fine. And just change this to elements. Elements. And then also be careful, man. That would have been a disaster. That would have been a huge disaster. So let's actually set up the vertex array. So GL gen vertex arrays one, and then the memory address of GL VAO. Just bind that. Wait, let me just like make it before them then. Oh, should I already have this open? Okay. Dude, I forgot where I was instantly. There you go. RD GL VAO. This is bind our vertex array. And then when we want to do the actual vertex attributes, at location 0, wait, let me just like keep looking at my. Okay, at location 0, we have a vector2 of GL floats. They're not normalized. We don't care about normalization here. And the size, the stride, is just going to be size of a single GFX vertex. And the offset is just, I'm going to use offset of. It's just, I think it's an std_def.h, I'm not sure. So you pass it the struct, the type, and then you pass it the member name, basically. And then we just copy this like 3 times. And also GL enable vertex attribute array. My god, this is a mouthful and doesn't even make sense. So yeah, 1, 2. Here we do a little 1, 2, and here we have 4 floats, and here we have 1. And here we have the color. Here we have the texture ID. Instead of doing 2 and all that, we can just do size of. Not, I mean, no, not really size of. No. So yeah, that is basically it. I think we can also here. Let's actually update this shit. So rather than using GL buffer data, so rather than doing the whole array, we're just gonna update what we, how many plots we did. So basically, I'm gonna have to console docs.gl for this one, because I know how to use buffer data. I literally just used it, but I don't know how to use sub data, which is what we're gonna use here. Basically, we're just gonna update the vertices that are on, the GPU with the ones that we have on the CPU that we just updated here. Oh, and here also I forgot. We're just gonna set the rendered quad count. We're just gonna set it to 0. We're not gonna keep track of what we drew. So GL buffer subdata. Let's go. Let's do this. Come on, load quickly. Why is it so slow? So the target, we need the target, of course. GL array buffer, and then we need the offsets, which is always gonna be null, always gonna be 0. The size, which is going to be size of. Okay, it's going to be how many quads we render, and then multiply that by 4, because and then multiply. So now we have how many vertices we've updated, and then multiply that again by the size of a vertex. We're doing this in bytes. GFX vertex, and the data itself, which is just quads. We're just gonna pass in quads, just like that. Pretty easy. And then let's actually draw, GL draw elements. And I mean, we've already bound our vertex array, and we're already using GL use program. So like, I'm not gonna rebind them because they do have some overhead. So GL draw elements. Uh, I also forgot this one. Damn it. GL draw elements. Elements. Good. Where is it? Oh, GL3. There we go. So we need the mode, which is probably GL triangles, of course. How many of them? So how many quads, basically, and then multiplied by 6, I think. Wait, what count? Specifies the number of elements, so number of indices. So yes, it is literally 6. And then the type, which is, yeah, I mean, each index is a uint32, so GL unsigned int. I mean, I usually do uint16, but also because you can have many quads, and you're just gonna like overflow because you're just gonna overflow the unsigned short is gonna overflow. Just use an unsigned int at this point, and the first index in the array to yeah, null. There we go. Not sure if this is gonna work. We're probably gonna have some compile errors. And also, why am I still? I'm so used to using the terminal. And also, another thing is I forgot to. I mean, what if I do? Wait. Let me experiment around with them. That's not gonna help. Okay, sad. So let me just go to issues. Uh, yep. Okay, we need that. We're passing something bad. We're passing something bad. So a glue buffer subdata makes integer from pointer without cast. Expected GL int PTR. So just pass 0 there. We still have an error. Interesting. Very interesting. Oh, it's just a typo. Just a typo. Just a typo. And we have a vertex shader compilation error. Error whatever. Too few components to construct a vector 4. There you go. I just cached it. We still too few components to. Yeah, I literally just. Oh yeah, right. 0.0 on the z-axis. Shader program link in error, and it just doesn't show me anything. That is beautiful. That is amazing. Love that. GL link program. There we go. Yes, I love OpenGL. It's so good. We have an error. Oh, RL, dude, this isn't Raylib. Hey, look, there we go. And for some reason, our color is absolutely fucked. So what's going on? Main.c. Oh, I didn't like even set it. So if we go and do a little color, which is a vector 4s, and then we do. Damn it, I forgot. Let's just do red. Red is always the best color for testing shit. And there we go. We've got a render, dude. This render is so advanced. Also, let me just shut those pieces of shit errors that nobody cares about. I'm too lazy to, but still. V2, it takes in an x and y, and it's just gonna do vector 2s. Do a little macro because macro expansion, just in case, because macro expansion is scary. Do the same shit for vector force. No, damn it, I love Vim, bro. So good, changed my life. Fucking hell. Do the same shit here. Z and W or Z, whatever you want to say, and here's the vector 4 instead. And then when we go here, we're going to replace this with a V2 instead. So it's more convenient now to type. And same shit here. So I'm just going to like delete all this. Just do a vector 4. And now we can go to our GFX. I don't have Harpoon because this doesn't have any plugins. And we'll do the same shit here. I mean, I've already went ahead and typed this, so like I'm not gonna do the whole V2 again. I'm just gonna like do this. This should be good, right? No compiler warnings. There we go. Now, last but not least, this video is 49 minutes. Okay, that is scary. Well, in that case, I'm just gonna implement one last thing, which is make the camera actually useful, right? So what does the camera have again? Let me just generate a little CTAG file so I can go to definition. Okay, yeah, we need camera projection. Yes, right. Well, let's go to our shader. let's add a little uniform, call it matrix for U projection, the U underscore, so it's a uniform. And then just multiply that, multiply that matrix by, yeah, there you go. So rather than using normalized device coordinates, we can actually use, normal coordinates, duh, right? And then we can go here. Now, dude, I am terrible at matrix math. I am going to fuck this up so bad. So here, camera dots projection equals to, okay, first of all, we need to GL uniform matrix for FV, and then I completely forgot uh, GL uniform matrix for FV. Just gonna give it the little thingy. And also, before I forget and start like debugging and shit, let's do render data GL dot U projection location. You'll get uniform. We can get the uniform location from now. Just a bit of caching. Pass it the OpenGL program, the name, which is literally just this. We can close this now. And here, oh, we have all the uniforms. Okay, that's neat. But where's the one I asked for? So the location, we gave it the location, which I've already got here. So U projection location. I can probably do auto completion now, right? So like if I do this, it'll just auto. Yes, that is convenient because I've done the ctags file. The count, which we have one. Transpose. No, we don't do that, please. And the value, which is just how does it look like actually? Wait, I forgot because this isn't my API. CGLM struct matrix 4 dot h. Let me look at it. No, I want to look at the actual structure, not just. Yeah. So it's literally just matrix dot raw. So I can do something like camera dot projection dot raw, and it'll still work, right? Shit. 0. Is that gonna work? Nope, not really. Dude, I am just trying random shit. I'm not even like focusing or anything. Wait. So how do you do this? Do you do like M and then 0 0 like this? Like, does this even exist or does it not have a member? Okay, it does not even have that member. That is odd, not odd, but still. Wait, let me go there again. Is grep for union matrix for S? It does not exist. That is lovely. Oh, never mind. I found it. Yes, type structs. Man, I love grep. Wait, what was it again? Line 275. 275. Oh, it's literally just okay. Literally just M00. So just give it the memory address of that, and please just shut up. There we go. It's not gonna work, of course, because we have nothing in that matrix. So camera dot projection equals to GLMS ortho. We're going to use orthographic projection. Yes, I know, very huge. Now we have to get the. Okay, shit. We have to get the actual shit. Right. We could probably use GLW get window resize, or what we could do, something else we could do is. Here's a bit of a retarded solution. I'm just gonna go to GFX here, all the way to the top, static U in 32. I'm just gonna have a window width, so win width and win heights, which by default equal to. I mean, now that I think about it, it should be here, but still, you know what I mean. So we're just gonna have this, and by default it's gonna be 800 by 600 or 720. Why not? Right? Before including GFX, and here we're just literally just gonna use it casually, right? So here is gonna be doing floats, win width, and then I forgot honestly. I think it's left, right, bottom up. So the bottom is going to be the window heights. So because if you've ever worked with 2D, the more we go on the y-axis, the more down we'll go, basically. And then the actual closest, so minus 1.0 and 1.0. And then we're gonna actually apply our transformation. I'm not gonna do that for now, just to test. And also we need a little thingy, little GLW thingy. So frame buffer resize callback. And here's gonna be GLW window, the width, the height. GL viewport is gonna resize our actual OpenGL frame. I mean, thank God this isn't Vulkan swap recreation. You know, swap chain recreation. That would have been a pain in the ass. And then the window width is gonna be equal to width, window height. I bet you didn't know this C syntax. I'm just flexing at this point. That is basically, let's actually assign this. So GFW set frame buffer size callback. Man, that's a handful. The frame buffer. No, wait. Generate. Man, this is actually kind of convenient, not gonna lie. I'm gonna start getting addicted to this. Now, it doesn't work. Beautiful, because I am not even using this piece of shit. Okay, so it's a big ass window, but we got nothing. Why is that the case? Am I not doing this correct? I'm not doing the window projection correctly? I am not sure. Let's actually just go there. Wait, so can I just go to definition here? Probably not. Yeah, I don't even blame it. CGLM. We're gonna grep for. Actually, let's just use Vim for this one. We're gonna grep for GLMS ortho. Float left, right, bottom, top. Left, right, bottom, top. It is near Z, which is -1 and 1. So I am correct on this one. Oh, well, I think I know why. It is a stupid reason. It's because the size is like only 1 instead of like something big, like 50. There we go. Yep. So now we can do some shit like how do you do keyboard inputs in GLW again? GLW keyboard input. We can actually do a little player, not really player, but still vector2s position, which let's just zero it out. And here the position equals to literally position. And here we're just gonna do a little update. So input guide. Well, yeah, I forgot GLW had nice, really nice documentation. I will admit. I don't want a callback. I want the actual thing. So if GLFW gets key, gonna give it the window and the GLW key. Let's just say right, or let's just do WASD equals to GLW press. Not sure if I want press. I don't want to press exactly. I want like hold. Yeah, we'll see as we go. Then we basically just do position.x plus equals. We don't really have delta time right now, so let's just code that real quick. So float current time, last time, and delta time, right? And then current time equals to GLFW get time, and let's just cast that to a float, a little floaty. Last time equals to current time, and before that we just do a little delta time equals to the delta between them, so delta time minus last time. So here we just do plus equals like 50 and multiply that by delta time. Let's just copy this a bunch of times, but this time it's going to be d a just down, nope, up, down. What am I doing? Yeah, just change these to y. And here we do a minus, we do a minus, we do a minus. We are so bad, guys. And there we go. Look, I'm moving a little render. This video is way too long, as you can see. I will do the Sprite Atlas so you can actually render atlases and not make a freaking Minecraft 2D, but worse. Don't worry. See ya. I am dying from the inside. I'm kind of tired right now. See ya.